What's going on, scholars? Mrs. Harp here with another math lesson. I've got a live audience. Make sure you click like and make some comments. And if you can subscribe, that'd be great, because I'm halfway to 20 subscribers. Thank you very much. All right, so today we are doing exponential decay. Very similar to exponential growth. So did you bring your graphing arms to class today?
No. Yeah.
All right, go like this. Go like this. What's that called? Exponential growth. Go like this. Go like this. That's your exponential decay. So I believe on the notes yesterday had you sketch it. So if you have it sketched yesterday, you don't need to re-sketch it. But it looks like this. It has the same exact asymptote as the exponential growth did. That's at y equals 0. This is exponential decay. And what causes the equation to create a graph that's decaying is the growth factor itself. The growth factor, if it's between 0 and 1, it will cause decay. So the growth factor of 1/2, 1/3, 2/5, those would all be decaying. Pay for one ticket. Who wants to try domain and range? This is pretty easy. Maddie, go. Okay, and what about range? No, we can't go down here. There's an asymptote. So an asymptote means we can't go past that boundary. So we can't ever go down here. So good. 0 through infinity. Okay, do you have your calculators ready to rock? They're charged up. I had to charge mine at that. People borrow it. Go ahead and type this equation into the graph, and then we'll fill out the phone. So our growth factor is 1/2, so this will be decaying for sure. The values will be getting smaller. All right. Did you click table yet? Should be 8, 4, 2, and you can see how it's getting half as big. That's because of the 1/2 growth factor. 1.5, 0.25, and 0.125. And then you can just click graph to see it. There it is. It's definitely decaying. So I'm just going to plot a few points and get my overall picture sketched. It doesn't have to be perfect. Hey, if you want to be a real scholar, you'll draw that asymptote in. Where would it be at? Megan? Be a scholar. Everybody can be a scholar. It's 2018. All right, ready for another one? This one is weird. Take a peek at it. What's the growth factor? 2/5, so it will be decaying because 2/5 is a number between 0 and 1. How do you think this negative out front will affect the graph? That's what's weird. How does a negative affect a parabola, for example? Remember our parabolas, chapter 1? A negative out front flips it upside down. Well, this is going to be exponential decay, which looks like this. The negative out front will flip it upside down. So it'll be really cool. Let's go ahead and type it in. Oh gosh, he types fast. Okay. So for your table, did you get negative 46.88? Okay, so we're matching. Negative 18.75, negative 7.5, negative 3, negative 1.2, negative 0.48, and negative 0.192. So it's a little bit weird because it's a decay graph that flips. It's kind of down here. Do you think the asymptote is still at 0, 0 if the graph is flipped upside down? Yep, it is. Because when it flips about this x-axis. So the asymptote doesn't. Flip graph, see what you see. Looks like it crosses at negative 3. And it looks something like this. Hey, let's do domain and range. Just give a ticket out and practice domain and range a little bit more. Who wants to try it? All right, Megan went ahead and volunteered and is going to give us a domain and range.
So the domain is all real numbers, and the range is 0 to negative infinity.
Good. And somebody in my last class said it backwards. You want to start with your smallest number, negative infinity, and go towards your largest number.
I said that.
And Mackenzie, you pass that back.
I even told Maggie that.
I actually called on you, Mackenzie, and you gave me a look like, why would you call me?
I even told Maggie that.
Moving on. Yep. Yeah. So the range is where this graph is allowed to go on the y-axis. And this is our y-axis, this guy. So the graph can go down as far as it wants to on the y-axis, which is negative infinity. That's way down there. But it can only get as high as here, because there's an asymptote you can't cross. So this is the highest value it can technically attain is like negative 0.0001. So we say that 0 is its boundary. We put a parenthesis there because we don't want to include 0. Bracket. All right, there's no need to write this down if you wrote it down yesterday. So let's just recap yesterday. What, if I have a number in for h, how does that affect the graph? Left, right, slide. Yep. And if I had a number in for k, how would it affect the graph? Up, down, slide. Yep. So we're not actually going to graph these next two, but we're just going to state how it would slide. So how far would this slide to the right or left? 1 left. I heard somebody say left. And then what about up and down? 2 down. Perfect. Any questions on that one? All right, next one. How far would this one go left or right? 1 left, and then up and down? 2 down. Yep, I heard some people saying it. Perfect. We only have one more topic to talk about, and that is depreciation. Have you heard that word? What's appreciation mean? It's gaining value over time. Depreciation is something that loses value over time. Can you think of an object that would lose value over time? Your car. Yes. Your house normally gains value unless you live in a neighborhood that is going downhill, and then it would lose value. Your dog? No. So go ahead and write down the equation in the pink box, and we'll talk about how you use it. I put it on the board, and I called it the depreciation equation. The main difference between yesterday's equation and today's equation is this guy, the minus sign, because we're losing value today instead of gaining value. Losing money, not gaining money. All right, 2 more problems. The first one's for Cole. It's a snowmobile. It's depreciating 10% each year, and we're going to figure out the value after 3 years. So, what's the original cost snowmobile? That's going to go in for A. $4,200. How much is it losing value each year? But we need that as a decimal. Good. And then if you want to graph the scenario, you'd put an X right here, because they do say graph it. We're going to skip the whole graphing part because we would need to change our window to be able to see up at 4,000. So we're just going to figure out the price 3 years later. So we can put 3 in for X. Go ahead and type it in. Gosh, you typed it in so fast. Can you read that slowly for me? 0880. Okay, just trying to remember. Perfect. Questions on that? How that formula works? And then we're on our graduation problem to see if you can graduate the lesson. So, go ahead and try to see how much this car would be worth in 2018. And if you can get it, you graduate. All right, so the answer was 3,219.76. I hope you graduated. And just for fun, this car was depreciating 9%, but do you have any guesses what the average depreciation is? Like per year. What percent per year a car would lose its value? Because I Googled it.
12%.
So it's higher than that. In the first year, it's actually 60%, because when you drive it off the lot, that's when it first loses the most value. And then after that, it's between 15 and 25% per year. I find crazy, crazy, crazy. All right, so we are done. Here is your homework.